Hey everyone, in our last video, we built an interleaved oscillation shader in raw WebGL, the same kind of dynamic, rippling effect you see in classic EarthBound battle backgrounds. If you haven't watched that one yet, I definitely recommend checking it out first. The link's in the description. Today, we're taking that same shader and bringing it into Phaser 3 using a custom PostFX pipeline. To save time, I've set up a simple starter project for you. It includes a basic scene that renders out our background image using our full canvas, a basic scene that renders out our background image using up our full game size, PostFX pipeline we'll use for the effect, a Tweakpane UI so we can adjust the shader parameters live, and a simple helper that visualizes sine waves so we can actually see what's driving the motion. Everything else, the asset loading, setup, and rendering, is already handled. All we need to do is add our shader logic and wire up the uniforms. Here's our pipeline class. Right now, it's just a basic pass-through shader. It draws the texture without changing anything. Our shaders are already set up with our custom uniforms that we'll need to create our effect. These 6 uniforms are going to control both the horizontal and our vertical oscillations. Our amplitude X and our amplitude Y are going to define how strong our displacement is from when we move our pixels. These 2 values define the height of our sine waves that we're creating. Our frequency X and our frequency Y, these control how many waves will appear in our sine wave and that it'll appear across our image. Finally, our speed X and our speed Y are going to control how fast our sine wave is going to move. This is what creates our animated motion for our effect. So now for our pipeline, in our onPreRender method, this is where we update our uniforms for each tick of our game loop. We'll pass in all of our parameters, and we'll rely on Phaser's built-in caching to only modify our uniform values if they've actually changed. These will all be passed to our GPU so our shader can animate smoothly. Besides our 6 uniforms, we have one more for time, and this is the amount of time that has passed since our game has first started. We're going to combine this with our speed to get our animated effect. Now over in our Phaser scene, we just need to make sure we add our pipeline to our renderer, that way we can attach it to our background image. We add our pipeline to our renderer by doing add post pipeline, then we do set post pipeline to add our pipeline to our game object. Now for the rest of our code in our Phaser scene, this is just tied to the additional game objects we've created for our demo visualizations here and for our Tweakpane integration. Our Tweakpane integration allows us to adjust all of our parameters live. This makes it super easy to experiment. You can crank up the amplitude for intense motion, or reduce it for subtle ambient effects. So as we change our X and Y frequencies separately, this is what creates that rich, interwoven weave pattern, and that's what gives the interleave look its character. So in this video, we won't be doing a deep dive into the code that makes up the shader effect, or discussing the math behind it, since we went over that in a previous video. In our last video, we covered this in depth, so if you are interested in learning more, I recommend checking out that video. There'll be a link to that video in the description. Now that we reviewed our starting project template, let's add in our shader code. So now to create our effect, first we need to create our sine wave for our horizontal displacement. For that, we'll do a float. We're going to call this wave X. We're going to set it equal to our sine function. We'll want to do our out text coordinate. We'll want to take our Y coordinate. And now we want to multiply that by our frequency. So we're going to do our U frequency X uniform. Now we want to add in our U time and multiply that by our U speed X uniform. Now that we have our sine wave for our horizontal displacement, we need to calculate our offset. So we'll do another float. We're going to call this offset X. We're going to set this equal to our wave X float. We're going to multiply it by our amplitude. So we'll do our U amplitude X. And now this will give us our offset for our X coordinate. So now for our interleaved oscillation effect, we need to do the same thing for our Y value. However, we'll be taking our X coordinate and multiplying it by the values for our other sine wave. So we're going to copy these 2 lines of code. We're going to paste them. We'll update our float. We'll do wave Y. We'll do our out text coordinate. We want to do our X value. We'll multiply it by our frequency for our Y. We'll add in our time. And we'll multiply by our U speed Y. And now we want to do our offset value. So we'll do our offset Y is equal to our wave Y multiplied by our amplitude, but our Y amplitude. Now that we've calculated our offset for both our X and Y, we can calculate our new position for where we need to sample from our texture. So we'll do a new vector 2. We're going to call this new chords. We're going to set it equal to a vector 2. Now we want to take our original x position, so we'll do our out text chord x. We'll add in our offset for our x. Now we want to do the same thing for our y position. So we're going to do our out text chord, our y value, plus our offset for our y. And now that we have our new position, we just need to sample that from our texture. So instead of using our original position, we're going to use our new coordinates. So now if we save and we come back to our browser, we're going to see our new shader effect is being applied to our background image. So if we go ahead and update our speed for both our x and y to be 0, we'll see how our sine wave is being applied to our pixels in our image. So if we update our amplitude to be 0 for both our x and y, we'll have our straight lines. Now for our horizontal wave, as we increase our amplitude, that's going to increase the offset for how much we're going to move our pixels to the left and right. If we increase our amplitude, this is going to increase the offset for our pixels to go up and down. And so with how we set up our integration, we can tweak our values for both our horizontal and our vertical waves separately to create unique effects. And because this runs entirely on the GPU, it's incredibly efficient. You can layer multiple effects, apply it to animated backgrounds, or even use it in battle scenes for that classic retro vibe. And that's our Interleaved Oscillation Shader running in Phaser 3. With just a few parameters, you can replicate the energy and movement of those legendary EarthBound backgrounds right in your own games. If you'd like to learn the math and shader logic behind this effect, check out the first video in this series. It walks through exactly how the oscillation works step by step. Thanks so much for watching. If you found this helpful, give it a thumbs up. Leave a comment with other shader effects you'd like to see, and don't forget to subscribe for more Phaser and WebGL tutorials. If you want to support the channel and help me keep making videos like this, I've got a Ko-fi page. Links in the description. Every coffee helps. See you in the next one.